My name is Klug. I work as a software developer / solution architect at a company called Active Solution in Stockholm, where we do Microsoft-based development, custom development for clients. But we also spend a lot of time engaging with the community, and that means that I go to a lot of conferences and I talk at community events, and we try to share knowledge as much as possible, which is, I guess, why Microsoft made me a Microsoft MVP. But the topic of the day is dynamically adding functionality to ASP.NET Core applications. And it might sound like a sort of a esoteric thing to do, but it all started out with, I went to the Azure portal, and I do a lot of Azure development. And if you create a web app in Azure, you have this button where you click Turn on Application Insights. And I was like, how do they do that? How can you press a button and add functionality to an application that doesn't know what Application Insights is? I found that to be really impressive. So I went down a rabbit hole of trying to figure out how that works, and I found a solution. I am pretty sure it's not the solution that they actually use in Azure, but it's a solution for doing it. And when you go down this route, you figure out that there are actually three problems that you need to solve. So the first problem that you need to solve when doing this is, how do you load code that is unknown at compile time? How do I actually get code into an ASP.NET Core application if the application doesn't know that code exists when it starts up, or when you compile it? And the solution to that is that there's actually an attribute called hosting startup attributes that you can use to tell an assembly that it should get loaded into ASP.NET Core or in .NET. And there's an iHosting startup interface that you can implement so that you can play around with the actual host that you run inside of your .NET application. And then there's an iStartup filter inside of ASP.NET Core that allows you to play around with the actual request pipeline. So what you end up with is you create this class. If we go from the bottom up, you create a class that implements the iStartup filter. So any class that implements iStartup filter that's registered in the IOC container in ASP.NET Core is actually allowed to take part of the request pipeline setup. So as long as you register an iStartup filter, whenever ASP.NET Core is getting to the point where it's setting up the request pipeline, it will ask any of those startup filters, hey, do you want to do anything with the application builder? So that allows me to plug in dynamic middlewares into my application. But that's not kind of it, because we also need this, which is a class that implements iHosting startup. So iHosting startup is kind of the same thing, but at a higher level. So this tells .NET that, hey, I want to plug into the host builder. So instead of plugging into the ASP.NET Core pipeline, I want to plug into the host. So whenever your application starts up, it creates an iWeb host builder or web host builder, and it configures the host, and then it runs ASP.NET Core inside of that host. This tells the system that, hey, I want to be a part of that configuration, which then allows me to go in and create this. I have to create this configure method that gives me access to the host builder, which allows me to inject services into the host. And as you can see here, I'm injecting my startup filter into the IOC container inside of the host, which means that the filter is going to be there when ASP.NET Core loads, and ASP.NET Core sees that iStartup filter, it asks what we want to do, and then I can add things to the request pipeline. And we also need to tell .NET Core that this assembly that contains this iHosting startup, we have to add an attribute to it to say that, hey, I have one of those iHosting startup things inside of this assembly, and here is the type that is going to implement iHosting startup. So that's a way for us to basically be able to tell .NET that, hey, if you look here in this assembly, if you look at the attributes for that assembly, you'll find an attribute called hosting startup that will tell you what class implements the iHosting startup stuff. Once you have that, you have to go away and add some environment variables on the machine that's going to run your code. So first of all, you need to add an ASP.NET Core hosting startup assemblies attribute, telling ASP.NET Core the name of the assembly that contains the startup stuff. And then there are a few more that we're going to get into once we look at this. So at this point, we've been able to load, or we've added code so that we can load our code into the ASP.NET Core application. But how do you load assemblies then that aren't known at compile time? So it's fine that I can create an assembly that has the iHosting startup and that loads my functionality, but how do I get an assembly loaded into the runtime if the application doesn't know about it at compile time? And you use something called the deps.json file. So whenever you build an ASP.NET application, whenever you build a .NET application, in your output directory, you will actually get a deps.json file. And that deps.json file tells the runtime what assemblies needs to be loaded. So the one that you see on screen now is a very simple one. There's an application called My Application version 1.0.0. It doesn't have any dependencies at all. So when the runtime loads up this My Application, it basically will only load the myapplication.dll. That's it. But we can add other things in here. So any dependencies can be added in here as well. And what we can do is we can actually tweak our own dependency file, our own deps.json file, and say, hey, any application that is going to run ASP.NET Core should also load these other assemblies that I have here on the side. And then once you have one of those deps.json files with all the assemblies that you want to load into the runtime for your applications, then you add an environment variable called .NET additional deps, and you point at a folder that in turn contains a little folder structure that tells the system when to load what assemblies or what dependencies, depending on what application is starting up. And the final part we've got, the final thing we need to figure out is, how do I add those extra assemblies to my server so that the runtime can find it, right? Because normally when you start your application, the runtime will basically look in the same folder as the DLL file that you're starting up, and then any other dependency will be in that folder. We won't have that because it won't know about my assemblies or those dynamic assemblies until runtime. And the way you do that is you create something called a runtime package store. It's if you've been around for a long time like me and you've done old classic .NET framework stuff, you know about the global assembly cache where you could store assemblies in a global cache that was available to everyone on your machine. This is not it. There were issues with the global assembly cache that most of us ran into at some point if you worked on that. But this is basically just a folder. It's a folder where we can put all of our dependencies, and then we can tell our server that, hey, whenever the runtime is looking for an assembly or a dependency, and they can't find it locally, then have a look in this folder as well. So we can preload all of our dependencies onto a server and then have those being loaded from a different folder instead. And this can be used not only for this, you can also use it for optimizing your Docker images, for example, preloading your dependencies to your base image and then not have to deploy them with your application, for example. But to create one of these package stores, there's actually a built-in command in the .NET CLI called .NET Store. And you give it a manifest file, which is basically a CSproj file that defines what packages you want to put into your runtime store. So it's a lot like a normal CSproj file in its structure and everything, but it's not for what I want to use for my application. The project file is just there to basically define what packages do I want to put into my store. So you can have more than one version of the same assembly, for example, which doesn't work if you run it in a program, so to say. And then you tell it what runtime to run, and then where you want to put your runtime store, and then you add this skip optimization at the end. And don't ask me why, just it needs to be there. If it's not there, it fails and it blows up in your face. So just trust me, just leave it there. And then once you've got your .NET store or package runtime store, then you just add, once again, another environment variable to your machine saying that, hey, there's a shared store on this machine. It's located at this address here. So whenever you're looking for an assembly that you can't find locally for an application, hey, run over to this folder over here and have a look to see if you can find it there. So that's kind of how it works. And I'm not a big slide guy, so let's just go and do this as a demo and see how that works. And I'm going to do it reverse. I'm going to kind of start with the runtime store and then go back from there. So let's go ahead and cancel that. And we have a little application here where you can see I have my VS Code. I have a couple of terminals. One terminal is, this left one is the same as you see here is in VS Code. And the right one is where I'm going to publish all of my stuff to, so I can work in both the source and the destination part of it. And the first thing I need to do is create a runtime store. So I have this runtime store folder, and inside that I have a CS project file. And as you can see in my CS project file here, it's a CS project file as you expect. It defines a target framework. You can ignore that thing for now. I'm going to use that later on. But it has package references. That's all there's in here. And you can also see that I'm actually adding both version 12 and 13 of JSON.NET, just as an example, to show you that you can have more than one. And once again, ignore this comment down here. I will put that in use in a little while. But with that CS project file, what I can do now is I can actually go to my terminal here, and I can run .NET store to say that I want to create a runtime store. I do -- manifest to say that I have a manifest, and that's going to be located in the runtime store, and it's going to be called runtime store CS project. And then I tell it that the runtime this is going to be running on is going to be a Win10x64, so it's going to be on my local Windows 10 machine or Windows 11. And then I go output to tell it where to create my store. So I'm going to put that in C:\\ASP.NET Core, ASP.NET Demo and runtime store, like that. And then don't forget the skip-optimization at the end here, because as I said, it fails if you don't have that. So we run that. It complains a little bit that the yellow output is just saying that, hey, you have a duplicate package reference, and that's fine. For a compile, that obviously is not going to work. You need a specific version, but for this, it's fine. So just ignore the warning. Now that creates a folder. So if we open up Explorer here and we have a look at it, you can see here that wasn't all supposed to be in there. Sorry, got to delete that. So what we got in here is the runtime store, and inside that we got x64, we got net7. And inside here, we've got a folder for each one of the packages that I got. And for example, for that's not supposed to be there either. Sorry, I should have deleted this before. Newtonsoft, you go in here, you got version 12 and 13, for example. And inside one of those, you can go in and you can scroll down or go in, you can see you've got the assembly in here. So, but we also get this artifact XML, which can be quite interesting to have a look at. All that really is an XML file that tells the runtime store, or anybody consuming that runtime package store, that these are the packages that you will find inside of this store. So it doesn't have to go and traverse through all the folders. You can just look at this XML file to see is whatever I'm looking for available in this runtime store. So now I have a runtime store on my machine. That's kind of simple. It wasn't that complicated to create. So what I can do now is, if we go to my trusty terminal here and we clear the screen, and then I'm going to go and build this Enterprise Employee Management Inc. application. What it does is completely irrelevant. I stole it from another demo I have. But what we can do is .NET, and we'll do a publish. We're going to publish that as a release. We'll publish it to C:\\ASP.NET Demo web, like that. And what we want to build is that. I just build this, nothing complicated. Run that. And it runs as expected. And if we go in here, we go ls, you'll see that wasn't very useful. Let's go and show you like this instead. You will see that inside ASP.NET Demo, I've got a web folder. And inside here, you can see that it's compiled it. There's nothing weird here. It published it. It included bcrypt.net, Newtonsoft, Image Sharp, and all of that stuff. So it compiled just as you'd expect it to. Nothing complicated. But if I'm going to send this application to a server that has a runtime store, then everything becomes a little bit different, right? Because I don't want to have it send along the Newtonsoft and the 6 labors or Image Sharp and the bcrypt.net, because that's already going to be on my server. So I'm actually going to remove that. And the way that we do that is we go ahead and we copy that artifacts file. So I'm going to go ahead and I'm going to do a copy of that thing, runtime store. I'm going to go to x64.7 artifacts XML. So I'm going to copy that, and I'm going to copy it to the Enterprise Employee Management Inc. folder, like that. And I go back here, and what we can see here now is that down here, there's very little room on this screen. Sorry about that. Oh. We can see that it copied in the artifact XML. So now we know that this is going to be available on the server. So what I can do is I can go into my project file, and I can uncomment this line here. And this line basically just says, here is a manifest file that will be for a runtime store that will be on the server that I'm going to be deploying this to. You can also add it as a -- manifest to .NET publish, or if you don't want to have it in your SysPart file. By just adding that, if I rerun my publish, no changes out here whatsoever, I rerun my publish in here, it publishes my application. And if I go out here and have a look at it, all of a sudden it doesn't include any of those assemblies anymore. It only includes my Enterprise Employee Management Inc. assembly. So it removed all of the rest of them, which then means that if I go into my web folder here and I do .NET enterprise.dll file and I try to run that, it's now going to say that I'm a crappy developer because I've obviously missed something. And if we scroll up, it basically says could not load file or assembly in newtonsoft.json, which kind of makes sense, to be perfectly honest. So what we'll do is we'll go ahead and we'll add that our shared store to an environment variable. So what we'll do is set up an environment variable called .NET shared store, and we will set it to ASP.NET demo /runtime store, like that. And now with that environment variable in place, we can go ahead and run the application again. And as you can see, it loads up without any problem. You can't actually see it, but here it is. It loads up my application without a problem because now it finds all the assemblies that it wants inside of that runtime store. So that's part one. We have a runtime store. Now let's go ahead and look at that dynamic stuff that I'm saying that I want to add. So I have this other project here called Request Diagnostics. And the Request Diagnostics, it's kind of what you saw in my PowerPoint presentation. It has a little simple service here. It has an interface of iDiagnostics log. It's really stupid. It logs and gets all of the log entries. And the actual implementation is even dumber. It basically stores all of your entries in a list of string. And when it starts up, it basically ensures entries. That call will go and read out all of the entries from previous entries from a log file. And then when the application is stopping, it basically writes all of the log entries as a JSON object to that file that I defined up here. And all the log and get content does is basically it gets all the entries and it adds an entry. That's it. Really stupid thing because it's slowly going to just get bigger and bigger and bigger, and it's going to suck. But it works for what I want to demo. And then I've got this middleware piece here. So the middleware that I want to put into my application, all it really does, it injects that iDiagnostics log here at the end. And for every incoming request, I log the date and time of when it happened, the method and the request path. And then it also says, hey, if you have browsed to /diagnostics, I'm actually going to circuit the whole request pipeline and basically go and just dump out the entire list of log entries as a text file to you so you can read it if you want. Otherwise, just carry on with the rest of the pipeline. So to get that into the application, I have now created a diagnostics startup filter as well, which is what I showed you in my slide. So it's a class that implements iStartup filter. Inside the iStartup filter, when we configure the application, I go ahead and I add my middleware. And then to get my iStartup filter into the IOC container, I have a diagnostics hosting startup class that implements iHosting startup. When it runs, it goes to the configure services method. It adds the diagnostics log. It adds my startup filter. So it adds everything needed. And then I've also added this assembly level attribute called hosting startup attribute to say that, hey, this assembly contains an iHosting startup implementation, and here is the type that you want to use. That's kind of it. And if we have a look at it, I've also done one more thing. I've told it to generate NuGet packages on builds. So if I go ahead and I build that project, we'll go here and say .NET build request diagnostics, like that. You will see that it's going to go ahead and generate in the bin folder a NuGet package for me. So there's a request diagnostics.NuGet package or nupkeg or whatever you want to call it. So if I want to use that, it needs to go into my runtime store because it needs to be loaded from the runtime store. So I'm going to go to my runtime store again. And I'm going to go ahead and I'm going to say, hey, I want to reference this package here called request diagnostics. And because I'm not loading it from NuGet, I actually just update the restore sources up here to say that, hey, don't just look at NuGet, go ahead and look at the debug folder as well for the request diagnostics, so it can load the NuGet package from that folder instead. With that in place, I can go and recreate my, my store if I run that command. Once again, if we go back out to my demo, my runtime store, we have a look in here, you'll see that request diagnostics is now available in the runtime store. So we've got the runtime store running, we've got the application loading stuff from the runtime store, I've got my NuGet package in there. The last part is for me to get that request diagnostic stuff actually loaded as well. And for that, I needed that deps.json file, right? So what I've done, and the simplest way to do that is I need a deps.json file that loads the request diagnostics assembly. That's about it. And since I know that the runtime store actually does that, I'm going to go ahead and just comment out the 12 version of JSON. And then I've added a stupid program.cs file that doesn't actually do anything. It's only there to allow me to actually build that project as well. So if I now go ahead and say .NET build, and I build the runtime store project, I don't really care about that project. I don't care about the program file. I don't care about the project as such. All I really want is that runtime store.deps.json that gets generated. Because this deps.json file is basically saying that to run this application, you need to load the runtime store, bcrypt.net, newtonsoft.json, request diagnostics, there it is, that's the one that I want, and image sharp. And then down here, it defines the different packages. I don't need to load the runtime store assembly, and I don't need to load the bcrypt.net assembly. I do need newtonsoft.json, and I do need the request diagnostics package, but I don't need image sharp. I'm just going to remove those extra entries from this deps.json file. So now I have a deps.json file that references the two packages that I want to dynamically load into my application. So to get that to be read, what I'm going to do is I'm going to go to my trusty old terminal again. I'm going to say make dir. I'm going to create a directory in the AceNet demo folder. I'm going to call the directory additional deps. And then it needs a shared folder under there. And under that, it needs microsoft.aspnetcore.app and version 7.0.0. Anything that runs Microsoft, the Microsoft ASP.NET Core app version 7 is going to read these additional dependencies. Then I'm going to go ahead and I'm going to copy my runtime store bin debug. That was not what I wanted. I'm going to copy the bin debug net7 runtime store deps.json. I'm just going to copy that to that folder, which is going to be copy it to c:\ASP.NET demo, additional deps, shared, Microsoft, blah, blah, blah. So into that folder, just shove it in there. That's what I want to do. So now I have an additional dep. So what I need to do, the last part in this puzzle is to go ahead to my application again. And I'm going to add two more environment variables. I'm going to add an environment variable called .NET, and I actually think I have this. So there it is. So I don't have to spell it all right. It's going to be .NET underscore additional underscore deps. And then I point at the folder that contains my additional dep stuff. So I just add that. Then I go ahead and I add one more, which is going to be the ASP.NET Core hosting startup assemblies, like that. So I basically tell ASP.NET Core, here is the assembly that contains this hosting startup stuff. It's going to be called request diagnostics. And if I then run .NET Enterprise DLL and run that, you can see that it starts up, which is a good start. It also says adding generic diagnostics to system. Diagnostics available at /diagnostics. If I open up my browser again in here, and I go to /diagnostics, like that, without caps lock, doesn't really matter, but there it is. As you can see, it logs every incoming request, and my middleware is inside that pipeline without the application actually knowing that diagnostic stuff ever existed. So what I've kind of built here is We do .NET My Application DLL, and that starts the runtime. The runtime looks at the .NET Shared Store environment variable to figure out that there is a runtime package store on my machine. Then it loads the required assemblies, which is going to be the My Application DLL and whatever assemblies it has defined in its deps.json. Then .NET is going to look, are there any additional deps or additional dependencies for this ASP.NET Core web app or Microsoft ASP.NET Core app version 7, and it's going to find that inside of the additional deps folder based on that environment variable. Then it's going to look at that deps.json, load those assemblies as well, because it was told to add additional deps to the runtime. Then it starts the application. The application starts ASP.NET Core. ASP.NET Core looks at that ASP.NET Core hosting startup assemblies and environment variable, finds request diagnostics. It asks to load, start the request diagnostics or load the request diagnostics assembly, which has been loaded by the additional deps, and it injects itself into the code. That's kind of my demo. I want to thank you all for listening. I hope you saw something that you might not have seen before. If you have any questions, just feel free to ping me on Twitter or get hold of me in any other way. My blog was mentioned in the previous slides, but Twitter is probably the easiest way to get hold of me. So thank you all.
Chris, thank you so much.
Thank you. That
flowed beautifully. That was lovely. Thank you so much for sharing that. We do have one question for you, and
yes.
So it is from Nick, the first one. So does that mean that this is also an opening for a malicious user?
It's not, because the user would have to get to your server to add environment variables. So it won't actually load anything unless you have those environment variables. And if the user, the malicious user, has access to your web server to add your environment variables, I am sorry to say, but being able to inject stuff into the application is your least of your problems, because you have other bigger problems at that point.
Okay, I see. And so how did you discover this? Why did you decide to kind of go on this journey with this talk?
Well, it did start out with that Azure stuff, with being able to add application insights to that's kind of where it started. And then for some reason, when I get something in my head, I kind of have to figure out how it works. So I ended up Googling a lot. And the feature is documented, and it's better documented today than it was 3 years ago when I looked at it. But once I don't know, when I get something in my head, I need to figure out how it works. And somebody has apparently got it to work. Having that said, I don't think the Azure guys are doing this. I think they're doing something much smarter. But I found a way, so I'm happy with that.
Yeah, amazing. Well, that's quite the engineering brain of you to try and figure out how it works. Yeah, maybe we could put you in touch with the Azure team to really kind of narrow it down if you wanted to.
That would be cool.
Yeah. All right, Chris. Well, thank you so much. I hope you enjoy the rest of your day. Beautiful Stockholm. And yeah, everybody watching, thank you so much. If you would like to reach out to Chris, here is his Twitter handle, and he's open for listening. Thank you so much, Chris.
Thank you, Jamie.